Hey everyone, welcome to this video on model evolution metrics, the heart of every machine learning project. In the next few minutes, you'll master accuracy, precision, recall, F1 score, and ROC curve, the key to judging any model performance. Stay tuned till the end to become an evolution pro. Building a machine learning project is only half the job. The real success comes from knowing how well it performs. Just like students are judged on many things, marks, behavior, and creativity, models too need multiple evaluation metrics for paid results. Choosing the right metric depends on type of problem, the business goal, and data balance. Common metrics include accuracy, precision, recall, F1 score, and ROC AUC. The confusion matrix is the foundation of all classification metrics. It compares what model predicted versus actual results. There are four outcomes: true positive when the model correctly predicts a positive case, true negative when it correctly predicts a negative case, false positive, a wrong positive, or false alarm, a false negative, a missed positive, or missed detection. Accuracy tells us how often model predictions are correct. It is calculated as the number of true positives and true negatives divided by all predictions made. For example, if 90 out of 100 predictions are correct, the accuracy is 90%. It works well when classes are balanced, but can be misleading when data is imbalanced, like 95% is no disease and only 5% is disease. Precision tells us how reliable our positive predictions are. It answers the question when the model says yes, how often is it correct? For example, if the model predicts 100 patients have cancer, but only 80 actually do, the precision is 80%. Precision is most useful when false positives are costly, like in email spam detection, where you don't want to mark an important email as spam. Recall, also called sensitivity, tells us how many actual positive cases the model can find. It measures the model's ability to catch all relevant cases. For example, if 100 patients truly have cancer and the model detects 80, then recall is 80%. Recall is most useful when false negatives are costly, like in medical diagnosis, where missing a sick patient is worse than a false alarm. The F1 score balances both precision and recall. It is harmonic mean of the two. A high F1 means the model performs well in both metrics. For example, in fraud detection, we need high recall to catch most frauds and high precision to avoid false accusations. Between these two models, model B is more balanced overall, showing better performance in both precision and recall. The ROC curve shows how well a model separates positive and negative cases. It plots true positive rates or recall on the y-axis and false positive rate on the x-axis. The AUC or area under curve measures overall performance. A value close to 1 means the model is excellent, while 0.5 means it's no longer better than random guessing. So higher AUC means better model discrimination. Choosing the right evaluation metric depends on your data and goal. For a balanced dataset, use accuracy. It is simple and effective. When the dataset is imbalanced, F1 score works better as it balances precision and recall. If false positives are costly, go with precision. If false negatives matter more, choose recall. And when comparing different models, ROC AUC gives a fair threshold independent comparison. In email spam detection, every prediction can be classified into four cases. True positive, spam correctly marked as a spam. False positive, a real email wrongly marked as spam. False negative, spam that slips through and is not caught. True negative, genuine email correctly delivered. The goal is to keep high precision to avoid false alarms, high recall to catch all spam, and use F1 score as the best balance for real world performance. Here are the key takeaways. Accuracy alone is not enough. Always check precision, recall, and F1 score. Use confusion matrix to visualize how your model performs. F1 score gives the perfect balance between precision and recall. ROC AUC is great for comparing models and tuning thresholds. And finally, choose your metrics wisely based on real business impact, not just numbers.